Hello Algebra 2. This video will help you prepare for the first semester final in the class. Now make sure that before you watch the video that you have tried the problems on your own. Also make sure that you pause the video anytime you need to catch up with the writing and listen to all of the audio because I'm going to talk through lots of hints and helps on each of the problems that will really prepare you for the final. So let's start with number 1. So this is in Unit 1. Also, get your notes packet out from this unit and you can refer back to your notes whenever you have a question. So in this, we're going to talk about transformations. The first thing to remember is our 3 parameters of a, h, and k. And I'm going to show them written in a quadratic equation. So the 3 numbers that will shift where the graph is of the function is a, h, and k. So for a quadratic, it's y equals a times parentheses x minus h squared plus k. So remember that the a value, whether it's in this equation or others, like an absolute value, is going to either reflect the graph if it is negative, or it can cause it to be a stretch, which means the graph will be narrower than the parent, and that number, that a value, will be greater than 1, or it can be what we call a compress or a shrink, and that's if the a value is less than 1. The h value will shift the graph left or right, opposite of what you would think. The k value shifts the graph up or down. So for number 1, to determine those transformations, first you need to pick out the a, h, and k values. So I'm going to underline them, and you should too. So notice that we have 5, which is our a value. We have 2, which is our h value, and 3, which is our k value. So I'm going to write those. And then if it's a number greater than 1, then that a value causes us to have a vertical stretch. For our h, the actual value is 2. We take the opposite sign, and that's going to shift the graph right 2. And then our k value is, as we see it, positive 3, and that will shift the graph up 3. Now look at number 2. Do the same thing. Notice this is absolute value, but between that and the quadratic equation, the values are in the same spot. So let's underline a, h, and k. So a is negative 2/3. So the negative causes a reflection, and then the value of 2/3 is less than 1, so that is a compress or a shrink. The graph will be wider than the parent. The h value, we take opposite sign, which is negative 2, and that's going to shift the graph to the left 2. The k value is negative 6, and that will shift the graph down 6. Now for number 3, you need to write an equation whose graph represents the indicated transformation. So let's work backwards, and notice we're starting with the absolute value equation. So let's get that equation down with where our a, h, and k values should go. Now if you read the problem, we are asked to translate 2 units to the left or right. That's an h value. And so that means we're going to introduce an h value of 2. And then a vertical shrink, so that's our a value of 1/3. So our h will be 2, and our a value will be 1/3. So now just build the equation. So you say g of x equals, instead of a, you put in 1/3. And then it's x minus a negative 2, and we'll just simplify that so it's x plus 2. So remember, if you're shifting to the left, you're going to see plus the value. If you're shifting to the right, you're going to see minus that value. It's opposite of what you would think. Numbers 4, 5, and 6 review linear equations. So remember, as you're working these problems, get one of our reference sheets so you can become familiar with the formulas that you'll have in front of you when you take the final. So these 3 problems work with the equation of the line in slope-intercept form. So y equals mx plus b, where m is the slope and b is the y-intercept. So number 4, to graph the line, we want to get it into that form. So the first thing you want to do is solve for y. So write down the equation and then move your x term away from the y on the left side. So add the 4x to both sides. You get 2y equals 4x minus 2. Then divide everything by 2. So that you can isolate the y. So now you have the linear equation y equals 2x minus 1. You can easily pick out what the b value or the y-intercept is, which is negative 1, and that will be the first point that you graph. And then your slope is 2. Always think of slope in terms of as a fraction. So put it over 1. So slope is rise over 1. Sorry. So the first thing is you're going to graph your y-intercept point, and you can do this with any linear graph. Just solve for y. Start with that b value. So right on the y-axis, you're going to put a point at -1. Then from there, you're going to go up 2 and over 1 a few times, and then draw the line. Make sure you put arrowheads on the ends of your line. Number 5. Now we have to find the slope and the b value ourselves. So we have 2 points. We're going to call the first one that we see on the left x1, y1. So I'm just going to label it. And the second one is point 2, x2, y2. Now the formula for a slope is the difference in our y's, y2 minus y1 over the difference in our x's. So now let's just fill in the numbers. So we're going to take our y values, so 12 minus 16 over the difference of our x values, 15 minus 5. We get -4/10, which will simplify to -2/5. Now we're going to go back to that formula that I have up in the top of the screen, and we're going to plug in what we know so we can find the b value. So I'm going to plug in the first point that we see, 16. 16 goes in for y, so I say 16 equals -2/5 times 5 plus b. That's what I'm trying to find. Then I'm just going to simplify that fraction and then add the 2 over. So my y-intercept, my b value, is 18. I could have estimated that from the graph, but it's better to just work the equation and know exact. So now I can write the equation, and you can too. So it's y equals -2/5 x plus 18. Number 6, what is the equation that represents the table? So it's a linear table. We're going to pick 2 points, and I'm just going to pick the first 2 pair that I see on the left. I'm putting them in a box. And so I'm just going to do my formula. So I'm going to take my difference in y's, which is 1 minus 0 over my differences in x's, -4 minus a -6, which is like the same thing as adding 6. So my slope is 1/2. Now I'm just going to pay attention and realize that I have my y-intercept there because I have the point where x is 0, 0, 3. So I do not need to find that using the equation. I can just pick it out of the table. And now we can write our equation of the line. Y equals, put in our slope, 1/2 x plus our y-intercept number plus 3. In number 7 and 8, you're going to review how to solve a linear system. So number 7 is a system with 2 equations of lines. So you can solve it using substitution or elimination. I notice that the second equation has just a single y, so I'm going to use substitution. So the first thing you want to do is you want to solve that second equation for that single variable y. So I'm going to subtract my 2x over, so y equals -2x plus 8. Now here comes the substitution part. You're going to take what y equals from the second equation and plug it into the first. So 3x plus 4 times, and then we're substituting in -2x plus 8 for y. Now just do the math to solve for x. So I'm going to distribute my 4 and get -8x plus 32. Combine my x's, move my 32 over, and to be a negative, so I get x equals 7. Now remember to pause the video so you can catch up and you can understand what's happening. Now we have half of the answer, okay, because these lines are going to intersect in a point, an x and a y. So we have our x value. Now we're going to take that and plug it into either one of our original equations, and I like to plug it into the one I solved for y. And when I do that, I get -2 times 7, which is -14, plus 8 gives me a -6. And now I write that as an ordered pair. So these 2 lines intersect at the point 7, -6. You can always check your answer by plugging each of those x and y values into each of the equations and making sure you get a true statement. Your final will be a multiple choice test, so you could even work backwards from the answers and plug them in to see if they make each equation work. The pair that makes both equations work is your answer. Now remember 8, we have a 3 variable system, so I'm going to work it forwards, but notice that you have 3 answer choices. You could also work it backwards, where you take each of those values for x, y, and z, plug them into each of the 3 equations, and the one that works for all 3 of them is your solution. But I'm going to work it forward. So remember, we do this by elimination. So we're going to group the first 2 equations together. I'm going to multiply that top equation by a -1 because I want to eliminate my x's. So that changes all my signs in this equation. I'm simply going to rewrite equation number 2 underneath, draw a line, and I'm adding. So my x's will eliminate. I'll get 7y minus 8z equals 24. Now we're going to group the second and the third equation together. I need to eliminate my x's, so I'm going to multiply my second equation by negative 2. So I get negative 2x minus 2y plus 8z equals negative 24. So watch your positives and negatives. It's very easy to make a mistake. Rewrite that third equation, draw your line, and add. X's eliminate and y's will eliminate. We'll get 13z equals negative 39. Solve for z, and that is negative 3. Now we have two simpler equations to combine, and I've drawn an arrow between them. So 7y minus 8z equals 24, and z equals negative 3. So I'm just going to plug in that value for z and solve for y. So I get 7y plus 24 equals 24, and that's okay because I'm going to subtract my 24 and get 0. 0 is a legitimate answer. Divide by 7, y equals 0. Now I'm ready to find my third variable. I'm going to pick which equation looks simplest to me, and I like the second one. I'm going to plug in my values for y and z and find out what x is. So x plus, I'm plugging in 0, minus 4 times negative 3 equals 12. I'll just do the math to get x plus 12 equals 12. Subtract my 12 over, x also equals 0. Now I can see that my answer choice, and I could have seen that from the very beginning when I solved for z, but just to be sure is going to be D. And then just a note that you can always, when you're working with a multiple choice test in these types of problems, you can take your answer choices and work backwards, plug them into the equations to see which ones work or which one will work for you. Number 9, we're back to quadratics because the question said, what does a parabola, which is the graph of a quadratic equation, with one solution look like, with two solutions, and with no solutions? So solutions for a quadratic graph, a parabola, are where the graph crosses the x-axis if it does. These are called the x-intercepts. So if it has one solution, it's simply touching the x-axis in one point, so that will be the vertex. So you could have a parabola like this, where it touches down and just opens up into your upper quadrants, or you could have one that comes from underneath and opens downward. But it's only going to touch the x-axis once, and that'll be one solution. Now, two solutions means that parabola is going to cross twice. So it could look like this, where it's opening downward, crossing twice, or it could look like this, where it's opening upward and crossing twice. Now, this last one is very important to remember for your test. If you have a quadratic with no real solutions, that means the parabola will never have any chance to cross the x-axis. So it's going to look like something where it's floating up in those upper quadrants, or it's heading downward and floating in the downward quadrants. And so it would not be facing down in the upward quadrants. Otherwise, eventually, those parts of the parabola would cross the x-axis. So this is what a possible graph of a parabola with no real solutions could look like. In number 10, you need to describe the transformations from the parent function, which are the parabolas that pass through the origin 0, 0, and they are the red ones, to the new parabola, which are the blue parabolas. And so you want to use any of the terms that apply. So if the graph is shifting up, down, left, right, if it's a stretch, that means it's narrower. If it's a compress, that means that the new one is wider. And if it's a reflection, either over the x-axis or the y-axis. So we're going to track the vertex. If you look at A, and we look at the parent function, which goes through the origin, so we're going to track the vertex to the new one. And so we notice that the new vertex has shifted over 3. And so we have a transformation of right 3. And now let's see how far up that vertex is. So it is up 4. We also notice that the new parabola, the blue parabola, is opening downward, so that means it is a reflection. So is reflecting over our x-axis. And then we check to see if there is either a stretch or a compress, so if it's narrower or wider. So with the parent, I start at the vertex, and I go up 1 and over, and I hit the parabola. With the new one, I go, in this case, down 1 and over 1, and I hit the parabola. So that means they are the same width. So the new one is not narrower or wider. So now we're going to do that for the next 3. So we're tracking the vertex on B, and notice that it is up by 3. And then we're going to, it has not shifted left or right. Let's check if it is a compress or a stretch. So we go up 1 over 1, and with the new one we go up and over, but before we go a full step we hit the parabola, so that means it's narrower than original, so it's a stretch. C, we're going to track that vertex, so it shifts over left 2, and notice that the new one is facing downwards, so that is reflecting over our x-axis. And it looks wider, but let's check. So from the original vertex, up and over, and we hit the parabola. From the new one, up 1 and over 1, and we don't hit the parabola yet, so that means it's wider, so it's a compress. And then finally with the D, so track that vertex. Notice that it is moved over 3. And then it looks like the new parabola is narrower, but let's check it, and it is. And so if it's narrower, then it is a stretch. On number 11, we're going to build a new function, g of x, from our original, which is a parabola, f of x equals x squared. So we'll start it, and we'll say g of x equals, and we want to first do a vertical stretch by a factor of 4. And so we know that that is our a value. So we're going to have an a value of 4, a reflection over the x-axis, so that'll be a negative a value, so a negative 4, a translation 2 units right, and so that is our h value, and then 1 unit up, and that is our k value. So let's just go ahead and build that equation. So we want a reflection, which is negative, a stretch by 4. We're going to open a parentheses. We want 2 units to the right, so we're going to do the opposite. We're going to subtract 2 squared, because this is a parent function is the x squared function, and then 1 unit up, that's our k value, add 1, and done. So you just decide what each of those transformations, what values need to be changed in the equation, and then just change those in the appropriate places. Let's finish off this part of the review video by doing numbers 12, 13, and 14. So you're going to graph the parabolas and describe the transformation as much as you can from y equals x squared. So on 12 and 13, notice that we are in vertex form. So the first thing is you need to locate those a, h, and k values. So on number 12, we have a is 3, and so that means we have a stretch by 3. That's our first transformation. H is 4, and so we're shifting to the right 4. And k is 2, so we have a shift up 2. And so you know from vertex form that your vertex is hk, so let's write that. That is the numbers 4, 2. Make your xy table. We're going to put the vertex in the middle, and then just values to the left and to the right of our x, and plug them into the equation. So now we have 3 points, and you can graph the parabola. Make sure that you draw a smooth U-shaped curve through those points. So that is the easiest way to draw a parabola from vertex form. Let's try to get on 13. So locate your a, h, and k values. So a is 1, h is 2, and that means you have a shift to the right 2. K is 0, so no shift there. The vertex is 2, 0. Then make your xy table with the vertex in the middle. Step to the left and to the right of the vertex and the x values, plug them into the equation, and you have 3 points to draw your parabola. Number 14, notice the equation has changed. This is intercept form, so it's on your note sheet. All right, it's in the form that I've written here for you. So you know your two x-intercepts, and so you have a point at -1, 0. Remember, we take opposite sign, and at +3, 0. Now we just need to find the vertex. It's a little bit different than vertex form. So what you're going to do to find the x values of the vertex is you're finding the middle of p and q. You're going to add those up and divide by 2, and that gives you 1. Then to find the y value of the vertex, you're going to plug in 1 into the equation, and we'll get -4. So now we have the vertex, and we have our two x-intercepts. So just plot those 3 points, draw a smooth U-shaped curve, and that is how you can graph the parabola from intercept form. Remember, on your final, it's multiple choice. So if you're given a graph and then asked to choose which equation it is, and you can see that the equation is intercept form, then look at where that parabola is crossing the x-axis. And remember, in the equation, it's going to be opposite sign. So you would see it's crossing at -1, and you're like, aha, opposite sign, so that's +1. You see it's crossing at +3, and in the equation, it's going to be opposite sign. That will help you locate the equation that matches with the graph.